In this segment, I'm going to discuss standardization, and this shouldn't be anything new because you've had it in prior classes. However, what may be new is how to calculate some of these things in Excel and do it quickly. And also, I like doing this because it helps demonstrate conceptual concepts that you'll want to have solidified. So here, before we start in Excel, here is the formula. And for any given raw data point in a data set, we have that, and then we'll subtract off the mean of those raw data points, and then divide by the standard deviation. And again, what this does is it cleanses the data point from any units of measurement such that it can be compared across studies regardless of the units of measurement of the study. So, feet to inches, or kilograms to pounds to self-efficacy scores, it doesn't matter, because standardization really gives us a picture of where that data point falls in relation to the mean of the data set. That's all it does. So what I'm going to do is left click, then right click, and then worksheet object open. And that's going to give us what I have here. I put the ID of the participant here. That doesn't really mean anything. There are about 30. And this is the same data set that we've been working with where we want to predict a person's GPA from their GRE quant score, basically. So that's what we have here is the GPA in column B. And then in column D, we have the quant score. And this is old quant score. So this is a data set from an old textbook that I had on hand. So the GRE scores look much different now. But don't let that distract us, because this is just an example. Okay, so down here below in these rows, I put the sum and the mean and the standard deviation. And I just copied and pasted them all the way across regardless of what we were doing so that you could see how they work for all of these different variables. Some they're more meaningful than others, as we'll see. Okay, so I did the standard deviation. You can click in each of these, or a lot of these cells, and see the formulas that I put in. So STDev is the standard deviation for a given column or row of data, which you see here. And the main idea that I want us to pull out, one more thing before I go there. The z-scores are calculated with the formula, as you can see. And so this is just the raw data point given in B2. So this is the raw GPA. Subtract off 3.3, which is the mean that was calculated down here with average. That calculates the mean in Excel. And then divide by the standard deviation of these data points, which was given here in the STDev. I'm sorry, down here. So that's 0.6. So that's all that I did, and I copied that formula down, and that gives us the z-score. So you can do this in SPSS. It gives you that as well. You don't have to do the formulas in SPSS. You just pull down with the menu and click standardized scores. I think we'll do that next week, actually. But you can play around with it if you like this week. Same with the GRE quant z-score. So we're doing the raw data point, which is located in cell D2, subtract off the mean, which is given down below, 565.3, and then divide by the standard deviation, and then copy that formula down. Remember to get the standard deviation. We already had SPSS calculated down here. But these last rows columns are just me calculating the deviation score. So the raw data point for GPA minus the mean. These are the deviation scores. And the only reason I did this is to show you that they add up to 0. Same with our NFL example. So this is just another example or illustration of how that comes out. And so in order to get around that, we'll square that. Oh, I just realized that we need a caret here. That may change. Oops. never mind. The caret is here, and that's all that matters. That's just the title of the column. All right. I need to wake up today. All right, so this is the square for the GPA, and this is the square for the GRE. The square deviations, just so you have them. And then down here we can see that the z-scores, the mean is going to be 0, and the standard deviation and variance also will be 1 for both of these, for any time that you do. When you add up those z-scores, they'll always be 0. Just like when you add up the deviations, they'll always be 0. So that's good to know. And the z-scores, again, the standard deviation and variance will always be 1. Not so with the deviation scores, as you can see here. But that's not as important to know. Just know that the z-scores, if you took z-scores for the whole data set, added them up, what would the result be? And then if you took their variance and standard deviation, what would that be? And that's it. So feel free to play around with this, devise your own data set and do the same thing, whatever you like, and make sure that you see that these are always true. And of course, make sure that you take into account rounding error. If you don't have the exact mean, then you may not get exactly 0 for the sum of the deviation scores or the sum of the z-scores as well. So that sometimes happens. All right, that is all. That is the basics, the very foundations of what standardization means.